Welcome. In this demonstration, we're going to look at how you can calculate a dopamine drip. There are two methods of calculating the dopamine drip that we're going to cover here. In this case, you're going to see the 400 milligrams of dopamine placed into a 250 milliliter bag of fluid. Now remember that you need to remove an equal amount of fluid from the bag as what you're going to place in from the multi-dose vial. Now the method that you've probably seen before is this one, where you have a long mathematical equation. We're going to calculate the numerator, that's the number that ends up being on the top, by the number on the bottom, or the denominator. We'll need to know the fluid in the bag, that size, multiply that times the dose, and for dopamine, we're talking about a dosage range of 2 to 20 micrograms per kilogram per minute. We'll probably start at 5 micrograms, times the patient's weight in kilograms, and multiply that times 60 because we're going to be using a microdrip, or also called a mini drip set, and then divide that by the total amount of drug you put inside of the bag. Now we've got the numbers here for you where it's got a 250 milliliter bag, a dose of 10 micrograms in our case. We're going to start with that one for this example. The patient's weight is 176 pounds divided by 2.2. That'll tell us the weight in kilograms. Times that 60, which is a microdrip set. We put in 400 milligrams, and 400 milligrams equals 400,000 micrograms. So we need to calculate that out. So 250 times 10 times 80 times 60 divided by 400,000. Now since we have a lot of numbers on the top that are exactly the same as the bottom from the right to the left, those zeros, we can mark those out. That will leave us with 120 divided by 4. That means you're going to give the patient 30 drops per minute. To calculate the amount of rate that would be, we can divide 60 by 30, that number of drops. That means we'll give 1 drop every 2 seconds. And here we have the 250 milliliter bag of fluid, the dose of 5 micrograms per kilogram per minute. The patient's weight is 100 kilograms because we did the conversion using a microdrip set, divided by 400,000 micrograms in the bag. We can go ahead and mark out the zeros like we did before. That leaves 75 divided by 4, or that's 18.75 drops per minute. It's difficult to figure out how many drops that would be and the speed you would do it, so we're going to use something called the clock method to figure that out, at least as a rough solution. We'll mix the medication up, and we know that if we give the entire milliliter of fluid, we know how much drug is in it because of how we mixed it. In our case, we mixed it so that there was 1,600 micrograms in every milliliter, which meant for every 60 drops, you're giving the patient 1,600 micrograms. If we split the clock into fourths, every 15 drops is 1/4 of that total amount. So 15 drops is 1/4 of 1,600, or 15 drops is the same as 400 micrograms. Here is an example of an Excel spreadsheet that I use to calculate drug dosages with dopamine. I'll put in the amount of drug, which is 400 milligrams, the size of the IV bag, the dose for the patient's weight. We'll have to multiply that times the tubing size, and then that tells me the amount of drops per minute. And now we'll look at a slightly different way of doing it. We're still going to mix 400 milligrams and 250 milliliters of fluid. That's 400,000 micrograms. That gives us 1,600 micrograms per milliliter. But the new twist is we calculate how many micrograms there are per drop. In this case, is 26.667. Now that we know how much drug there is per drop, it allows us to calculate pretty easily how many drops need to go into the patient to deliver the desired dose. So we start by putting the medication into the bag. We mix it up and label it. It won't actually change color. This is just for illustration purposes. We know we had the 400,000 micrograms in the total bag. That gave us 1,600 micrograms per milliliter. That means we have 26.67 micrograms per drop. Our patient was going to get a dose of 5 micrograms per kilogram per minute at a weight of 100 kilograms, or 500 micrograms per minute. We can simply divide the amount of drug per drop by the total dose. So in this case is 500 divided by 26.7 gives us the same answer as before, 18.75 drops per minute. Thanks for listening. I think both these methods will work, and I hope they'll help you find at least one of them to help you